Notes, segments, midpoints, and bisectors. Content objective. I will be able to determine the coordinates of the midpoint in a segment when the given coordinates of the endpoints as represented in one-dimension or two-dimension coordinate systems. A point. This is a term, this is a description, an example. Midpoint is the point in the middle such that segment PM and MQ are congruent. A point on a segment, midpoint, I said midpoint from both endpoints. Well, a point is a midpoint of a segment if the distances from the point to each endpoint are the same. So another way I could replace this with a point on a segment, the same distance from both endpoints. So M is the same distance from P as it is from Q. Constructed. To get a midpoint, what we do here is we need a circle or a compass. So bigger than well, here's my circle. So I could put it here and try to put the center, and then I would do this, and then I would put the center over here to make sure that it's in the same place, and I would do this. And then I would get my straight edge and connect those two. So, assuming I centered it right. So then that would be the midpoint. But really, I should use a compass. Getting the same distance. So here's my low-key compass thing. So I would measure like that. Then turn it around and do the same thing. And then connect those two. And this would be perpendicular. Perpendicular bisector. And now I know that this is the same as this, congruent. So that's how you do it. What are the steps? So on a quiz, I would ask you to put these in order. Given a segment, where I would AB, step 0, 1. Draw circle sector, not sector, arc, arcs, centered at each endpoint. Two. So the arcs intersect. And 2, draw line, line segment through arc intersections. Okay, so 1, 1, 2. If you think of it like that. If you want to slow it down, you'd have to have this point and this point. It looks like I actually missed that point. Okay, label, draw, intersection of bisector and segment. That's your midpoint. Your midpoint. Okay, so the midpoint formula in one dimension is a plus b divided by 2, where the coordinates a, b are the endpoint segment. So if you approach this as a formula way, and I want to find the midpoint of FG, here's F and here's G. I could draw it, right? I could find it. Or I could put numbers on here. Since this is -3 and this is 3, so I'd have to add those together. What's -3 plus 3? And then take half of it, because I want to go halfway and then put those together. And this would be 0. So the coordinate of 0, right, is, well, the coordinate is 0 of the midpoint. There's no midpoint, so this would be M of midpoint of FG. I don't know. You want to say that like that. It's 0. Find the coordinate of the midpoint JK. Where's J? J is a -1. So let's take the absolute value of this, by the way. -1. And that's going to be added with, where's K? And a 4, plus 4. So why would I take the absolute value? I would not actually take the absolute value. So 4 minus 1 is 3 divided by 2. It's 3/2. So that's 1.5. That's right here. This point is between J and K. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. 5 this way, 5 this way. That's right. 3/2 is the coordinates. Okay. So here's another example. Example 2. The coordinates of the midpoint MAB, the number line is 3, and A is a -2. So here's A, a -2. And the midpoint is 3. So 1, 2, 2, 3. This is the midpoint. B must therefore lie on the other side somewhere over here. -2 to 3. That's a distance of 2 here, and then 3 more. So it's a distance of 5. So from here, I have to go 5 this way. 5 this way. So B must be at 3 plus 5, which is 8. Okay? Now, if the coordinate of the midpoint CD and the number line is 1, so we have this at CD is 1, and C is a -3. So let's think about that. Here's -3, right? Here's 1 to the right of -3. -3 is C, so that's C. The coordinate to the midpoint of CD is 1, so 1. This is the midpoint. So that's a total of 4, because 0 is here. That's 4. So I have to go 4 this way. That's D. So 1 plus 4 has to be 5. Now that's visually. How do I do this algebraically? Well, I know that this could be x. So -3, if I call this x, plus x divided by 2 has to be 8, right? I mean, not 8, 1. That's the coordinate, because one's the middle. So then negative 3 plus x, if I get this whole thing and multiply it by 2, is 2. And add the 3. Let's see. I get 5. And I get x. So x is 5. The coordinate is 5. Similarly, over here in this example, if the coordinate of the midpoint is 3, so I know that this coordinate plus this coordinate divided by 2 is the midpoint coordinate that I don't know. So midpoint, or m if you want, is 3. And a is negative 2. So negative 2 plus something divided by 2 has to be 3. Multiply both sides by 2. This means negative 2 plus x is 6. Add the 2, and x is 8. So yeah. Now, what happens if it's not on that side, but on the other side? We'll explore that later. Midpoint formula of two-dimensional system, where x... so what is this? Well, if you understood 1, then we have to do this. It's x1 plus x2 divided by 2. That would be the x-coordinate. And similarly, the y-coordinate, just do this. Yeah. Find the coordinates of the given midpoints. So negative 9 and 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's negative 9. And this is 8. So 1, 2, 3, 4, 5, 6, 7, 8. This is 8. So negative 9 and 8, halfway, would be negative 1 divided by 2. So it would be here. Negative 9 plus 8 divided by 2. That'd be negative 1/2. That's this piece right there. Now let's do the y's. That's a 3 and negative 7. So 1, 2, 3. That's 3. Negative 7. 1, 2, 3, 4, 5, 6, 7. Negative 7. So that'd be 3 plus a negative 7 divided by 2. So 7 take away 3, negative 4 divided by 2, negative 2. So between these two is negative 1, 2, is this point here. So this is the midpoint between negative 3 and negative 7, and this is the midpoint between the negative 9 and 8, which I have here. This is 8. And so negative 9, 3 is called this A. 8, negative 7, call this B. And this point here is the midpoint M of those two, which is this. So you see, that distance is the same as this distance. I mean my triangle. So this is the same as this. This is the same as that. Okay. Try it on this one. 3, negative 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. That's 3, negative 6. 7, 2. That's 3, 4, 5, 6, 7, 1, 2. So let's call this A. Let's call this B. And quickly just go 3 plus 7 divided by 2, comma, negative 6 plus 2 divided by 2, which is midpoint to M. That's 5, negative 2. So 1, 2, 3, 4, 5, 1, 2. You see that this is 1, 2, 3, 4. 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. So this is 4 over, and this is 4 over, 4 up, and 2 over. So this slope is the same as this slope, and these distances are the same. Since they're right triangles, by Pythagorean theorem, I know that A to M is the same as M to B. And so that is the midpoint. Formula works. Let's take a look at the notes. Example 4. M is the midpoint of segment AB with A equal to 0, 1, 3, M is to find B. So where is 0, 1? 0, 1, that's A. And the midpoint's 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. That's B. So, B. This is M, should I say. So, where's A? That's A. So I need to know 1, 2, 3, 4. That's 4. 1, 2, 3, 3. So this is a distance of 5. I need to go 1, 2, 3, 4. 1, 2, 3, and that's B. So this is M, and that's B. Where am I? Well, if M is 3, 5, to the 3, add 1, 2, 3. So that's 6. To the 5, add 4. So 5 plus 4 is 9. 6, 9. So B is 6, 9. Algebraically, you can do this. 0 plus some distance x has to equal, from 0 to 3, from 3, so 3 plus some 0 to 3 is 3. What am I trying to say? So if this was like x, y, x2, y2, then I could have said a different method. I could have said that the sum of the points 0 plus my x divided by 2 has to go to 3. So 2 times 3 is 6. 0 plus x is 6, so x is 6. Also, for the y's, 1 plus some y divided by 2 has to equal my y, 5. So 1 plus y has to be 10, so y has to be 9. That's the other way, algebraically. I like the geometry myself better. Here's another one for you to try. Just try it. Okay, and then I shall try it. The midpoint of CD is negative 1, 4. Negative 1, 1, 2, 3, 4. That's the midpoint. What are the coordinates of C if D is 3, negative 2? So 1, 2, 3, 1, 2. This is D. And this is M. So negative 1, 4. D is 3, negative 2. So I can do my triangle and find the other one. It's going to be over here. Or I can say that over here, C is some x, y. So I know that x plus the 3 divided by 2 is equal to negative 1. I know that the y plus the negative 2 divided by 2 is the y of the midpoint. So solving each of these, multiply by 2. X is equal to negative 1 times 2 minus 3. negative 5. Y is equal to 8, or 2 times 4, 8, plus a 2, because that's negative 2, you're going to add it, and that is 10. So negative 3, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 9, 10. It's right here. This is C, which is at negative 3, 10. So, is that right? So, negative 1, 4. Negative 2, minus 3, negative 5. Oh, it's supposed to be a negative 5. I'm sorry. No, it's not right. So negative 5, negative 3, and then 4 and 5. So it's actually over here. It's supposed to be a negative 5, which makes better sense visually. So 1, 2, 3, 4, 5, 6. That's 6, 3, and then 1, 2, 3, 4. That's 4 that way. So this is 4 and 6 up here. Then 1, 2, 3, 4. Yeah, to make the triangle. And that completes the segment. So this is the square root of 36 plus 16. You do the squares. Anyway, that means it's negative 5 and 10. Okay. Let's look at segment bisector. A plane, ray, line, segment, or point that intersects a segment at its bisector means two pieces, midpoint, that are the same. Okay. Example. Here's a segment, A and B. And roughly here's the midpoint. But how do I know that? Well, I can get pretend to do this. Get a plane, like a chopping knife. So use my little knife. It cuts my segment in half so that this is congruent to this. It could be this point right here, or it could be this line segment here. Say knife, K, N, F. N is the midpoint of AB. As the knife cuts it at point N, or segment KF of the knife. So a ray could also be a ray. So suppose this goes on forever. That ray can bisect it. The plane knife, plane E, right? So I did a plane, I did the ray, I did the line. If I make this go on forever, it could be a line that bisects it. Or I could just put a line that, like this, normal to this, that line L. Boom. Okay. Intersect the segment in the midpoint. Point is that it's got to be the midpoint. I called it N. B is between A and C, and so where does it say it's the midpoint? B is between A and C. AB is equal to this, BC is equal to that, AC is equal to 20. Solve for Y. Well, is B the bisector of AC? It is if the two pieces are equal. So let's draw this again. B is between A and C. So here's B between A and C. AB is 2y plus 6. BC is y plus 8. Okay. AC, the whole thing, is 20. So what does that mean? That means that by the segment addition postulate, 2y plus 6 plus y plus 8 has to be the whole thing. Part plus part equals whole. So 2y and y is 3y. 6 plus 8 is 14. Subtract the 14. 3y is 6. Y then, because I take half, is not half, 1/3, sorry, because that's a 3. And 6 divided by 3 is 2. Y is 2. But you have to go back. 2 times 2. I need to know what 2 times 2 plus 6 is. And I need to know what 2 plus 8 is. So, yes, since AB equals BC, which equals 10. Let's find that out, because this was AB and this was BC, the distance of that line segment, or the length of the line segment. Refer to this figure. Does this cut this in half? Does it bisect it? That's probably the question. Okay, so if UY is 5, this is 5. Label your drawings, draw your drawings. Find YV. YV. And so I don't know what YV would be unless I know that's the bisector. Oh, wait a minute. It says it right here. WY bisects U and V at Y. So if this is 5, then this is the same as this. So this is 5. And that means the whole thing is 10. So YV, that's the 5. UV, 5 plus 5, 10. And I'm done. Okay. Try this one yourself. 13.5 YV UV, or 13.5 and UV, which they forgot to put. Well, that would be them added together, right? So 13.5 and 13.5, 6, 7, and 2, 27. Okay. Now, UV is 18. That's the whole thing. 18. UY is 9. So if the whole is that, that's 9. This has to be 9. So YV, 9. Quick check. If this 24, if UV is 24, right? Then 24 divided by 2, or half of 24, is 12. So that's 12 and 12. 12 and 12. Okay. Refer to the figure below. This one bisects this one at Y. This is the key thing. At Y, this is cut in half. And it doesn't have to cut it in half perpendicular, just cut in half. That just means this is a half. This looks bigger than this, I'm just saying. Anyway, 4x minus 3 is from U to Y, so put 4x minus 3 here. Then this is x. And now I know the relationship. If I know something else, I know that they're equal because they're the same. It's a bisector. So 4x minus 3. So UY equals YV. This comes from this statement. If this, then this. So this is x. Solve it. Subtracting the x. Adding the 3. Negative x plus 3 equals negative x plus 3. So add the two equations together. This would be 3x. That'd be 0. This is an equal sign. That's 0. This is 3. Divide by 3, and you have 1. 3 times 1 is 3. So go back here and evaluate each of these. What is 4 times 1 minus 3 but 1? What is x but 1? So 1 plus 1. 1 and 1. 1 and 1. Okay, and the whole thing is 2. Oh, excuse me. uy is 1, and this is 2, the whole thing. Okay, now, quick check. If uy equals 5x minus 9, yv equals this. So uy, so I know that uy equals yv, so 5x minus 9 equals 2x plus 12. This is the part, this is the whole. The two parts are equal, so which is smaller, 5 or 2? Well, the 2. So subtract the 2x. Now that you're here, add the 9. Put the equal sign, add the 9. That's 3x. And this, 0, and that's 0, and this is 21. Divided by 3, take a third. So x is 7. If that's true, what is 5 times 7 minus 9? What's 2 times 7 plus 12? That's 35 minus 9 and 14 plus 12. Take away 5. 30 minus 4 is 26. 10 plus 10 is 20, and this is 26. Indeed, the part is 26, and the whole is 52, because 26 and 26 is 52 when you add the two parts together. Okay. If uv equals x plus 6 and y equals x minus 1, uv is the whole. This is the whole. uy is the part. So x minus 1 plus x minus 1, x minus 1 plus x minus 1, or u equals the whole thing. So uy, which is, this is x minus 1, and this is x minus 1, because they're the same. But the whole thing is x plus 6. So add them together, and they have to equal x plus 6. So writing this equation here, x and x is 2x minus 2 equals x plus 6. Subtract the x, add the 2, and add the 2. So that's x. Equals 8. So 8 minus 1, 7 and 7. 8 plus 6 is 14. So indeed, this is true. So this is 7. And the whole thing, not that they're asking me, but here it is 14. Okay, quick check. Let's try this. uv, this is the whole. This is the part. You could also say that 6x minus 10 equals twice x plus 3. So that's 2x plus 6 equals 6x minus 10. Subtract the 2x, add the 10, add the 10. This is 16. These are equal. And so this would be 0, and this would be negative 8x. And take 1/8 negative. So it'd be x equals 16 divided by 8 is negative 2. So this whole thing would be 6 times negative 2 minus 10. That doesn't make any sense, does it? What would be negative? And uy is negative x plus 3. So it'd be 12, negative 22, question mark. So then this would be x would be negative 2 plus 3 would be 1. Oh, messed up somewhere. So where did I mess up? Let's see. 6x minus 10 is from u to v. uy is x plus 3, so x plus 3. But x plus 3 is 2x plus 6, 2x plus 6. The algebra. So I'm going to subtract the 2x, right here. 6 minus 2, obvious mistake. So let's do that again. So 6x minus 10 equals 2x plus 6. Doing this again. So subtract the 2x, that's 4x. Add the 10, 16. X is 4. Okay, so if x is 4, then this is 24. Then over here, this is a 4. And 6 times 24 minus 10 is 10. 14. So if this is 4, then 4 plus 3, 7. So this is a whole and this is a part. And each part was 7, as before. So it turned out to be the same. Okay. Here's the practice for this. Segments, midpoints, and bisectors. Here's your practice. So this is one dimension. Use the formula when you add the coordinates and divide by 2. And you have 2 coordinates. Do the same for 2 coordinates, or draw them. And the algebra. Okay, thank you.